The webcast today is going to touch on some of the topics that we're going to cover in the IoT hacking course very lightly, but it's largely going to focus on components because as Rick and I were talking about the course, one thing that we realized was that people don't necessarily have a background in electronics when they try to go and do IoT hacking. So we wanted to give some basic information on top of the stuff that we're going to cover in the IoT hacking course.
Yeah. So IoT hacking, what is IoT? For first thing, you need to define that. Really, it's just everybody knows what IoT is, or at least has an idea of what it is. It's your Alexas, your smart refrigerators, smart washer and dryers now, smart stoves. Anything that's smart. There's industrial controls, robots, stuff like that, all connected to the internet. Doing different functions, stuff like that, range from household objects, as I described, and industrial controls. So we're going to cover the basics of how you can get started in IoT hacking. Welcome, and who are we? So, David, I'll let you introduce yourself.
I'm David Fletcher. My background is really, my entire career has been in IT. And over the last 7 years, I've worked for Black Hills and Bosec. But my educational background is in electrical engineering. So I spent a lot of time looking at electronics. And at BHIS, it's nice to have the opportunity to play with electronics because I feel like that money I spent on that degree isn't completely wasted. I've got a lab full of equipment in my basement, and Rick and I spend most of our time working with Ray Felch, putting together the labs for Way West Hackin Fest and Way West Hackin Fest. And if you've ever done one of the swag bag labs or one of the hands-on labs, that's usually something that we've been involved in.
Yeah, and so I'm Rick Wisser, and also I have a background in double E. I have a double E engineering degree as well, and I haven't been in IT like David my whole life. I actually worked at a contract manufacturer as an engineering manager, and worked my way up through that. So I was an engineer, I was a technician. Really played with all this stuff. Got to see it get built, got to test it. Really went through the testing process of that, which kind of bled over into where I'm at now, with some IT background schooling as well. So to kind of piggyback off what Dave said, if you ever did the Hall of Doors, that was David and myself. We put those together. That was probably one of the most memorable and funnest labs we put together for the conference. Our interests include, we both hunt and fish, hardware hacking, of course, we're always doing that, remodeling, building stuff, teaching knowledge, the volunteer, so on. So IoT, we have, today they're saying there's, more than 10 billion connected devices right now. They're expecting that to go to 22 billion by 2025. They're saying 83% of organizations have improved their efficiency by introducing the IoT technology. I have my theory on that. Dave, what do you think? Why do you think that is?
Yeah, I think having automation in an organization, being able to sense activity is an important component. When you look at some of the projects that are upcoming, like vehicle to vehicle and vehicle to infrastructure communication, if we're going to do things like autonomous vehicles, those types of technologies are going to become critically important. So when you think of IoT, think of literally anything around you that can be sensed and support an automation capability. Same deal with like medical devices. Instead of having to go through a bunch of different tests, maybe I can swallow a device that's going to perform imaging inside my body rather than sticking me in something like a CT. Obviously, those need some form of wireless communication protocol. And as an attacker, maybe I can take advantage of that.
Exactly. And so, you can see here, there's going to be so many devices connected per minute they're expecting, and then also the economic value. It's going to be huge. So it's kind of why we're going through giving this class. Intro IoT hacking. What's exciting about IoT hacking is all that stuff. I mean, think of not just automotive, but they're talking about coming out with robots who look like humans and stuff like this. This is AI, stuff like that. So very exciting industry right now, and kind of trying to do some groundbreaking stuff to get into it. So we have other disciplines, IoT hacking, it's not just like a web test where you go and test that web, but it may include that. So it may include all these disciplines plus more, mobile testing, network testing, wireless, and so forth. The IoT hacking encompasses many of these skills, and really what we're going to highlight on in this webcast is hardware identification, basic electronics, and go through some research just to kind of get you started. And then with our class, we dive in and we do some more hands-on stuff, a lot of hands-on stuff, which you'll see if you take the course.
Yeah, and the course is very centered around the hardware. However, when you look at IoT, it's just like anything else. You have to look at that device within its ecosystem to identify potential vulnerabilities that might exist and have like far-ranging impacts. So if I have a UART exposed and I can get shell access to a device, maybe that's not a big deal. If it exposes a secret that's used on an entire population of devices, that becomes a much bigger issue. And then when I start looking at the environment, how that device interacts with the cloud, how users interact with the device, what network protocols it uses, those all become important components to the test. So it's very easy to zoom in on the hardware and focus on that. But from a risk standpoint, you kind of want to make sure that you're relaying that information in the context of the whole system rather than just an individual component.
Yeah, I agree. You do got to look at the whole picture and how they interface and stuff like that is definitely part of it. So IoT hacking, we just described so much stuff is embedded in the IoT hacking, that skills that you have to develop or obtain. Really, we're going to talk about the hardware. So we're going to talk about component identification, include resistors, capacitors, inductors, and so forth. And really, that's what these slides are about. And then we go into some research as well. So first, we got to talk about what stuff makes this stuff work, and really, it's the juice, the power. So we have current. Current, they consider that like the volume, the charged particles moving through a conductor in space, through the wire. It's measured in amps, and then you have your ground. Ground is your reference point. That's usually where you measure voltages from, and that's where the voltage goes to. The voltage wants to go to ground, always wants to go there, and it's common path return. Then we have voltage. Voltage, it's the work needed per unit charge. Considered pressure. We have alternating current as voltage, or we have direct current, AC/DC. As you can see on the slide on the right, we have alternating current is alternating, so it's up and down. It goes back and reverses directions back and forth, where direct current is pretty much one direction only and just, a constant line.
And when you consider like power in a device, it's very critical to understand what voltages are being used by what components, because the last thing you want to do is fry a component and let the magic smoke out. So if I try to power a device with AC when it's expecting DC, then I'm probably going to have problems. Or at the very least, the device is going to behave erratically. If I provide too much voltage, I might fry a component. If I have too much current available, I might fry a component. So being aware of those things is very, very, very important. Exactly.
So we talk about safety here because we're talking about voltage, right? So a lot of times we'll come across something we've had experience before. We've had a device that used 220, plugged it in 220, And then, of course, you have the case open, you're looking at it. You definitely don't want to put your hand on any of those 220 components or put your arm across it or anything like that. Yeah, so really got to be considerate of and understand where that voltage is at. It might trickle back down and supply only 5 volts to the board, 5 volts DC, but the incoming current and voltage is, at 240 volts. So many devices use those, especially in industrial controls settings. And then you also have device safety. The safety of the device, especially if a customer says, "Hey, here's a device. See if you can what you can do with it." You finally figure out how to open it up. You get into it, and there's a thing called electrostatic discharge, which is like just electrostatic energy. And that can fry devices too. When I worked at a contract manufacturer, we had to ground ourselves with wristbands to the tables and where the board's set and stuff, just so we took that precaution so we didn't fry a component on accident.
And so within the device, we talked about different voltage levels. Even though you may power a device with 110 AC or 9 volt DC, it's important to understand the components that you're looking at, because like a TTL component may use 1.8 volts or 3.3 volts or 5 volts, and making sure that you're using the right voltage with a given component protects that component from damage and you from buying another IoT device to have to test on.
Yeah, and we've seen that before, right? Where you maybe you can't get the flash off a device or something, and so you pull that device off the board, you desolder it, and then you go to put it in your programmer to take the program off, and you find out that it's 1.8 volts and not 3.3, and you just fried the device. So we're going to go into components here, talk about components really briefly. That you'll see when you open up a case, when you look at the board, you're going to see resistors. There's several types that come in different packages. You got ceramic, pin in a hole, like the ones on the right hand corner there. They have the bars on them that have tell you the value of them, orange, brown. And then you also have a resistor pack, which is the other picture there. And then the picture at the bottom, there's surface mount resistors. You'll see that they also are identified sometimes, not always, with silkscreen on the board. So you'll see like R36, C42 is capacitor, you got Q8 transistor. So you got all these devices that are referenced with silkscreen, but that's not always the case. So when I worked contract manufacturing, there was several boards that didn't have silkscreen on it. So you had to really rely on the schematics for that stuff. Capacitors. Capacitors store electrical energy. They block DC. They allow AC to pass. They're measured in farads. You can get them in different packages as well, surface mount, pin and hole. These are the ones that really, if something goes wrong, these are going to let out the magic smoke, or they're going to split in half, or they're going to do something, turn black and brown, catch fire. I've seen that before. So you definitely have different packages in that, and they're also variable ones. Variable ones are usually used to tune, like for radio frequencies, stuff like that, to tune in that radio frequency for that. Also, as David mentioned earlier, with the voltages and stuff, these are the things that if you're using, if it's got a big capacitor in there, these actually, like a battery, they store charge. So when I was in electronic school, we used to charge these CAN capacitors up there right here on the bottom there, and we throw them at each other, and they'd have voltage in them, and so they'd give you a snap if you touch the leads, with your fingers. So it was kind of a joke we did, and it got old quick, definitely.
You definitely don't want to throw around the capacitors that Lazy Sprocket is probably using in tube amp designs.
Yeah, no doubt. Those things are humongous. So inductors are, I kind of look at these, they're kind of the opposite of the capacitor. They block AC and they allow DC through. They store energy in a magnetic field. These things, you can charge them up and throw them, but they're not as bad as a capacitor. They may give you a little chuck, but not nothing. It's pretty harmless. These are used mostly in radio circuits, you'll find. And there's also different packages of those, pin and hole. And usually it's a wire around an iron core. So like this surface mount right here, this with the 220 on it, there's actually an iron core in the middle. And then they just have the wire wrapped around it, and they put a package around the wire as well. And same with this one, you can kind of see the wire in it. Diodes are pretty cool. I've worked with diodes quite a bit. Allows for current to flow in one direction. Pin and hole, there's service mount on these as well. And one thing you'll see this application for is really to convert AC into DC with a bridge rectifier. You'll see that, and if you want to Google that, you can see it's pretty cool setup. It takes the AC alternate current and converts into DC for you. Transistors are used to be huge. You know, if you're old enough to remember, or somebody's ever heard anybody talk about a transistor, they used to be these big glass tubes, and they used a crap load of power. Just definitely the transistors come a long way. Now they get them in these little packages. They use hardly any power. They usually use the amplify or switch electrical signals, and usually used in radio and TVs and actually all electronics now. Usually a 3-terminal connection, and there's the different chemical makeups of them, PNP versus NPN, and we won't really get into that, but they are made differently depending on what the design is. And then we got the voltage regulators. Voltage regulators, what they do, they regulate voltage. You'll see these from time to time, probably on every component, every device, and really just make sure that the voltage is within range for the device to work. You definitely don't want to put too much power into it. So this is kind of the safeguard for that. And then we get into the integrated circuits. These are the big ones, the big hitters. So these encompass all the components we talked about, and they put them in a package, and they make them really simple and simple form factor. Usually they're referred to as just chips on the board. So they perform what you would take a lot of space on a board. They pack it, condense it into a small package, and it does what would take quite a bit of real estate on a board to do. Just usually surface mounted. There's pin and hole. The ones up on top are pin and hole, and they get some surface mounts on the bottom here. And then also they're usually gold winged on a circuit board. And then you get the BGAs. The BGAs are specifically, it's really the way they are attached. And this is a series of balls on the bottom of the device that make the electrical connection to it, because you can't put, 500 leads on this device and mount it. So you have to do ball grids. And ball grids are usually used in microprocessors and other devices. Dave, you want to explain why these are a pain?
So typically, in order to do anything with a device, what we're normally looking for is some sort of lead that's going to allow us to connect to an interface. That interface could be a UART, it could be JTAG, it could be serial wire debug, I2C. But the point is, I have to have a lead to be able to connect to the device. With a ball grid array, all of the leads are underneath the device. So it makes it very difficult to directly access those leads. So you have to look for vias or an interface on the board itself that exposes the peripheral that you're looking for. And that could be another chip. So for instance, if I've got a BGA flash on a particular design, it becomes much more difficult for me to get flash contents read off of that device without shell access to the device or the ability to use JTAG. In some cases, I can just clip something to the device or connect to the appropriate leads and then read the contents, or desolder the device and read the contents. With a BGA, that becomes much more harrowing because you're not talking about 8 pins. You're talking about a ton of connectivity to the board. And if you don't have it, if you don't do it right, then you're just going to destroy something.
Yeah, exactly. seen it done before where, you find vias, and via on the board is where the trace comes out, and then it connects to another trace, and usually put a via on there. Usually it's for testing purposes. So when they test a device, like when I was in test, we test a device. We had a bed of nails, we called it. We called it an ICT machine. And what you do is you'd put that board in there, and it would suck it down, vacuum, and all those pins would make connections, and it would connect, and it would talk to all these devices and check for continuity, make sure everything's good. And it would also power up the device, make sure the voltages are correct, and also do some functionality. It might even flash the device and stuff through all those bed of nails. So if you can find the vias, you can do it, but good luck, because that's very hard to find, especially since you don't have access to the pins, like Dave was saying. Processors, yeah, we all know a processor. Got them in our computers. These things are These things are like the powerhouse. We got the central processing unit, which controls operations. Of course, microprocessors. Traditionally held the CPU, usually interfaces with CPUs, but now they're actually embedded. So the microprocessor actually might have the central processing unit contained within it. You also have the graphic process unit, which they start breaking that out. So, used to, back in the day, that the central processing unit controlled the graphics and everything. Now they found, to get the high resolutions that we're getting and stuff like that, they broke that out. So you're going to see this all across different devices. They might have different central processing units for different types of components that they're interfacing with to do different functionality. And then we have peripheral components. And peripheral components are just the components that connect to it. You got components that, like your keyboard and mouse. If you're talking about a computer, you got audio. You have a device that does Bluetooth, or serial and parallel connections. You don't see that much more. It's usually, if there is a serial parallel connections, it's through USB. It's more towards the old stuff. Remember those big cables, like the old printer cables, parallel printer cables, you'd have that connection. There's wired remotes, there's people might have a wired remote that they plug into it so to do something if the other remote doesn't work, and etc. Dave, do you have anything to add to that?
Yeah. So when you think about peripherals, like especially in IoT design, there are specific peripheral protocols that most microcontrollers support, like SPI and I2C. So looking for those peripherals in the design of the actual target device is a good idea. In addition, taking advantages of what the IoT device exposes to you is a wonderful way, just thinking creatively about how you might use something. For instance, if I can get shell access into a device that's running BusyBox, but BusyBox has been stripped of the binaries that I'm looking for, maybe something like NAND dump, might I be able to use peripheral access to upgrade my functionality? So maybe I grab a BusyBox binary, throw it on a flash drive, and then plug that into a USB port. Does that flash drive automatically get mounted? Does it use the no exec flag? Can I bypass that? What if I run BusyBox from the shell on the flash drive? Can I get that functionality to be exposed to me? So maybe I don't have NAND up natively in the BusyBox that's running on the box, but if I look at the right architecture, grab my BusyBox from the repo and then run it independently, I can still execute the things that I want to execute in the context of the machine, despite having had that stripped out.
Yeah, that's super cool. That's a cool concept. It's really, really cool that you can use peripherals to attack the device itself, and you might not even have to open it up. You might be able to get everything you need right from the peripheral connections. So we got over all those components. There's other components you run across. You're definitely going to run across components. You're like, what is this? What does this look like? Or what device is this? You might even have another device on top of a device, like a daughter board, as we called it, that does some functionality. I think we had some SCSI controllers when I worked for a contract manufacturer that I did a lot of troubleshooting on and fixed. And that's how that was interfaced, was through a header on the board. And then it controlled, really the read and write access and also the backup of the data, and it had batteries on it as well. So you might see, you might have the main board and you might have other boards on top of that. So now we got a basic understanding. Now we're going to move into research and reconnaissance. Really, this is my favorite portion. I love the research and reconnaissance because you just find so much stuff about the device. If it's out there, depends on how new the device is, but you can find stuff about it. You can find manuals, forums. It just depends on what you're looking for. Definitely my favorite part. And this is something that it's continuous. You'll go through, you might identify a chip on the device. You're like, what is this? Like I was just talking about, and you're going to go do some research on it, right? You're going to find out, what does this do? What is it? Does it store anything? Is it just, what's its functionality? And so forth. When you're doing that, you want to keep in mind that, how can I attack this? How can I take advantage of this and maybe get some information out of it? Depends on what it is, but it may communicate with something. So maybe you can capture, man in the middle of that communication or something to figure out what's going on with logic controller or something like that. Anything to add to that, Dave?
Nope.
All right. So let's go to reconnaissance. Like I said, the big thing is, and this, I've had this bite me before, identifying any tamper protection techniques. So, you could open the device up. Is it going to destroy the device? Is it going to make the device unable to operate? Sometimes it's just a switch, and it could be other things as well. And then identify interesting components and part numbers. Of course, you want to look at the part numbers. You want to find out what these parts do. You might find onboard diagnostic interfaces or interfaces through JTAG or UART or other things like that. Wireless features, protocols, frequencies. You might see antennas in there. And then really the big thing you're trying to figure out is the functionality of the device. And then how do I, break that functionality or make it do something other than what it's doing. And this is what research and reconnaissance does for you. Anything to add to that, Dave?
Yeah. When you're performing reconnaissance on the device, make sure you take advantage of all of the sources that are available to you. So like internal photos, how maybe some descriptions of how you might take the device apart. A lot of times, when you talk about tamper protection, understanding those features up front can save you time and effort, or might save a component. So like when we do destructive testing, we'll ask a customer, hey, we need 2 of these, because if we're doing destructive testing, it's likely that we're going to, end up destroying something for real. In some cases, we've had devices that have tamper protection, and when the tamper protection is tripped, the devices are meant to be completely unusable after they've been open without authorization. So flash gets erased, components get destroyed, and taking a little bit of time up front to identify where those tamper protection features might exist will save you some heartache. In one case, we did a bunch of reconnaissance, tore our device down, ended up frying it, and then on the second run, we just cut a hole in the case so that we could solder leads onto the JTAG connector. So just be creative about how you're approaching it.
Exactly. Manufacturer documentation. This is huge. If you can get manufacturer website, you can go there, look for documentation about the device, how it works. Maybe they have schematics. Most of the part they don't, but they may tell you how the device works and how to flash it and how to do all that stuff. You need to upgrade it. Product marketing literature is a good one. Downloads, of course. You got the firmware updates, the client software, the mobile application, and then another one is support forums. Maybe there's some that hey, this isn't working for me, and a lot of guys are saying this, and you're able to go back and look at it and say, hey, yeah, it's not working, and this is why it's not working, or it's not working, but I can take advantage of that since it's not working.
And when you look at manufacturer documentation, especially during the reconnaissance phase or after you've taken a device apart, not only do you want the documentation for the device as a whole, but whatever components you see inside the device. When you look at, if you've ever worked with a microcontroller, you quickly realize that the documentation for a microcontroller is immense. It can be hundreds of pages, whereas the documentation for a given IoT device may be nothing. It's unlikely that you're going to need everything in the data sheet for a particular microcontroller, but it'll save your life when you want to identify things like pinouts and voltage and tolerances. So it's worth investigating as you're performing reconnaissance. Just make sure you're thorough.
Definitely. Google's awesome, and enthusiast forums. There's people out there that they're this device is cool the way it works, but I'm able to make it do other things. And so somebody's maybe already done all this work for you, and you can go and look, hey, they're making this happen. Can I make it do other things too? So you can look at reviews of the device. So people might review it and say, hey, this thing didn't work when I did this, and or it did work, but I was able to get it to do this. You got the enthusiast forums, you got makers, and you got people, modders, third-party applications. You got teardown sites were really, really cool. Somebody might have a way that, hey, I tore this device down. This is how I tore it down. This is how I got into it. There's some hidden screws here. Instead of having to try to figure that out on your own and go, hey, how do I tear this down? Maybe there's a latch hidden somewhere that you can't get to.
Yeah, and when you think about these things, like one of my favorite references is like the Troy Hunt investigation into the Nissan Leaf. If you look at his blog posts, when he looked at it from, say, a hacker perspective, he quickly found out he wasn't the first one there. Essentially, people were so sick and tired of trying to use the Leaf mobile app that they were like, okay, I've done discovery on the APIs, and now I'm going to rewrite this mobile app so that it's usable to me. And that can be a really great starting point for testing a device. And it's great intel for an organization to say, hey, when we were doing reconnaissance, we found this stuff that gives an indication that people are already, manipulating your API without your knowledge. Is that something that you're willing to tolerate? Is it something that you should be exposing to them? It gives the organization under test food for thought when they're putting their product out there.
Yeah, definitely. It's like saying your stuff sucks. We're making our own. Kind of one of those things. That's a good story. FCC records. So FCC records is huge. We hit this whenever we can. You can do FCC ID search. Usually on the device, there's a sticker, especially if it communicates wirelessly in the United States. They have to file for FCC license, make sure that they're not, communicating at a frequency that's going to crash an airplane, of course, or walk over some other device that's like medical devices or something. So it really general search FCC ID database. You just put in the model number, and you get a lot of information back from that about the device, and that information you get is huge. One of them is schematics. So you get device schematics. They're not always there, but you can get schematics and you kind of understand how it's interconnected. And then if you have the circuit board in front of you too, you can kind of follow those schematics, look and see if there's, maybe they have comments in the schematics to say, hey, this isn't populated because it's, it's part of the JTAG interface. We don't populate it because we don't want to give people that can just hook into JTAG and get JTAG or UART. They might take resistors out, and then all you have to do is add a resistor in, of course, to get to the UART. So it's really just looking at the schematics and then, identifying where that traces go. This is pretty good too, and it can help if you get a ball grid array. You can actually see maybe, okay, there's a trace that goes over this component. Maybe I could just hit this leg of this component and this leg of this component, this leg, and I get access to that ball grid array as well. Photo disclosure. David talked about this. Definitely, here they got a list here of the related documents that FCC, requires. Some of them aren't there. Some of them they don't require them, but I think every device has all these links, but some of them aren't there. So they might not have internal photos, label and location. That's kind of just where they put their labels. External photos, the user manual, of course, is really huge, and so forth. And continuing with photo disclosure, they might have, like this device, they might have tamper resistant tech that you can identify through looking at the photos. Silk screen. Hey, they have silk screen on the board. That's going to make it easier to identify parts. Like it's this chip on it. If you have the schematic, this chip is the SPI chip, and this is the chip name. You can definitely go through there and look at that. Also, identifying chips, as I described, but sometimes you can get the markings right off the chip. You can say, okay, they're using this type of chip in there. You can go pull the data sheets, have those data sheets available already. Understand the voltage that it uses, understand what the functionality is of the device, and so forth, as we talked earlier. And then also, like I was talking, you might be able to find interfaces you can use, like JTAG interface, a UART interface, determine, hey, I think I can get something off this device through these headers. And sometimes they might even have the header. The header might not even be there. They might have silk screen that says TX, RX, and ground, or like this one says EJ tag on the bottom of the silk screen there in that one. So it's a JTAG device, and then you have to solder a header onto it. Or we have other ways of doing that we talk about in our course. And then the manuals, of course. Manuals are huge, come through. The manuals might even include default credentials, how to set up the device. Peripheral connections, as we talked about earlier, how the device functions, can it function with other devices? Is there another good thing to look at? Is there another series that's newer or later from that, and there's vulnerabilities associated with that series? Maybe it carried over into this series, so you can definitely do some research on that. And then intrusion detection, this might help you with it. Intrusion detections, maybe the documentation they have. Yeah, we get this switch here on this computer. This when you open it up, it doesn't run. It just disables it, and then wipes out the BIOS or something. Also, like I was talking, they might depopulate resistors. Like here, you can connect and get UART, but really you have no way of doing anything until you short those resistor pads. You don't even have to put a resistor in there. You just put a bead of solder across them, and it gives you connection. Really, just breaking that connection to the UART. There's you might find stickers like the void warranty stickers, stuff like that. RFID. NFC tags, you might see that in there. Is that something we can mess with, and so forth. And I think one time I was testing something. It wasn't me. It was somebody else who was testing it, but they had epoxied the whole board, so you couldn't do anything with it because it was made for aircraft, and they epoxied it all. So really, all you had access to without melting the epoxy and trying to get to something was just the peripherals from the outside of the device. So that's pretty good security there. I'm sure it cost them a lot. And IC markings. Dave, you want to talk about IC markings?
Absolutely. Yeah, I was getting a message, so I was caught off guard. So from with the ICs that are on the component device, you want to make sure that you grab those data sheets for each one of those devices as you identify them. So maybe you don't want to grab everything, but you definitely want to grab things like EEPROM, the microcontroller, any other controllers on board, so that you have a good idea of where things are in the design of the platform. Maybe what peripherals are supported on what pins of the device, so that it gives you at least somewhere to go, or a starting point for where you're looking at component functionality. In addition, as Rick has a link here for semiconductor logos, sometimes you can't read the markings on the IC, or one of my favorite tools, one sec, are these guys right here. So if I've got these guys on, it's really nice. It's got an LED up front. And what I can do is I can tilt the board so that even if it has essentially an invisible marking on it, you can pick out at least the logo and some of the markings. Some of this is going to take some Googling. So often what I find myself doing is looking up the logo and then Googling the manufacturer and part number to try to identify where I might be able to get a data sheet for a particular IC. That's not always going to be possible. Two that are notoriously difficult to actually get data sheets for because they require you to have an account and an NDA are Broadcom and Qualcomm. So I may or may not be able to find what I'm looking for, but I want to gather as much information as possible.
Exactly. Yeah. And those proprietary chips, those, like you said, those are hard. When I worked at contract manufacturer, I mean, we had to sign NDAs all the time when we were doing that stuff because they give us the schematics, of course, so we could troubleshoot the device if it was broken or while we were building device. So they really safeguard that stuff and don't let it out. And the logos, the chips, it's funny because the chips, usually through the build process, the board will get, especially pin and hole, they go through a wave flow solder, will solder put all the components on, they'll solder it all, flow solder the bottom of it. So it makes all the connections and solders it all at one time for them. And then it goes through some heating. It might go through surface mount heating. They put the components for surface mount components on, and it goes through like a pizza oven. You say it's, to flow the solder just enough without damaging the components. But once it goes through all that stuff, and then it goes through like a flux wash, once you get through all that stuff, sometimes those markings on those devices are very hard to read and very hard to get to. So for instance, this is one that was what Dave and I were looking at. We were trying to figure out what this, logos. We used the link that in the previous about identifying the vendor, and we looked, and it just and it looked like there's several of them. It could be, like, hey, it's this one or this one or this one. Which one is it? We just didn't know. So it was funny because Dave, we're both looking at it. Dave takes a picture of it and does just a Google image search, and we finally figure out it's a Giga device. I can't say that. Geez. Giga device logo. So then we are actually able to work out with, like Dave was saying, use your magnifying glass, your lights. We're actually able to figure out all that stuff. And identify the chip finally. And I think this device, there was nothing we could find there was no internal video or internal pictures at the FCC ID when we got that. So we really were just relying on what we could physically see. Manufacturer website. So you identify the IC, you identify the vendor, you identify the code, what device it is. You're going to go and look at it. Like for instance, this is an old product. So it said the device was not recommended to be used, although it was already used prior to that. So, as you see the status, it's mass produced, but it's not recommended to use. There's a newer version of this device out there. And you'll find information on that when you go through the data sheets, and it'll give you general stuff about it, and then also then more technical stuff about it as well. So you'll have pin connection diagrams, of course, pin descriptions, what's a pin to do, and so forth. And then if you really get it down to it, it'll tell you like some really crazy technical stuff that you really don't need to know, like if it's at this temperature.
Yeah.
Yeah. It's just some crazy stuff. I mean, have you seen anything that's really crazy, Dave, that you're like, I just don't think how to use it?
Not off the top of my head, but like if you look at the connection diagram on the slide, it'll help you orient. So like somebody mentioned SOIC clip in the Discord chat. That's an obvious tool that I would definitely have. And if you've never worked with an IC before, you'll notice that there's a little circle by pin 1 that's physically going to show up on the device itself. So understanding the orientation, understanding the other things that the data sheet are going to give you are the operating voltage, input tolerance, things like that are going to help prevent you from damaging the device and allow you to use it more easily. So you're not guessing at, is this pin 1 or is this pin 8? How does the pin numbering go? Stuff like that. Yep, exactly. The you are here dot.
Yeah, but we'll have to change that up. We should put you are here. I wonder if there's, so you can see the dot here on this device too. So there's a dot, that's pin 1, and 3, 4, 5, 6, 7, 8 goes clockwise. So there's still so much more to talk about. It's kind of all our webcast covers. Just kind of an introduction about components, stuff that we take for granted. Dave and I take for granted all the time when we're going into this stuff, identifying things, what we have. But just a brief introduction, kind of to our class. Definitely join us if you're able to join us in San Diego or Deadwood. We'll be teaching in Deadwood as well. And we'll cover several topics. Dave, you want to talk about those topics?
Yeah. From a topical perspective, we covered some of the attack surface analysis and reconnaissance in the webcast here, but we'll also dive into the myriad ways you can acquire firmware for a device, what you're going to do with that firmware afterwards, identifying wide-ranging or wide-impacting security vulnerabilities, performing static analysis on the firmware you've extracted from a device, and dynamic analysis using either UART connectivity to the device or an emulator. And then we'll look at, all of the stuff that you might be familiar with from a network pen test perspective. Does this thing do anything to prevent me from starting an SSH server? Is SSH bundled with the firmware that's on the device? Are there any debug symbols? Exactly. So things that'll help you along when you're trying to attack the device. And then we'll have some introduction to things like those peripheral or other testing disciplines. So if I've got an IoT device that understands RFID, well, what do I do with that? What if it does 802.11? Well, what do 802.11 attacks look like? If it's got a web interface, once you start digging further and further into it, things start to spider out quite a bit. So we just want to make sure that we touch on each of those individual disciplines so that you understand that, the IoT device is nice, but outside of its ecosystem, you might find, or you might not find, significant issues that can be severely security impacting.
Yeah, exactly. And to go on top of that, we got some tools we're going to give you, some hardware stuff, some device to attack, And then we're going to have, on top of that, we're going to have labs, and labs. We're going to try to get a lot more interaction, roll up your sleeves, dive right in, kind of get some familiarity with dumping firmware, doing stuff like that. And then on top of that, we're also introducing our new latest lab. We've been working on for San Diego specifically, since we are going to be on a battleship or around a battleship and stuff. But we do have our battleship game that we're doing. It's our own version, and I got a cutout of it. I'm working on it right now. So it's actually our BTLE. So it'll be Bluetooth Hacking Battleship. It's going to be super cool. And if you take our class as well, we bring it along anyway, and we built a lab. So we're going to set that up in our classroom, and you'll get first preview of that, and you actually get to play with that as well within our class. And so that's pretty much the conclusion of the webcast. Really everything we talked about here is just kind of an introduction, try to get you on track. If you have no experience whatsoever, don't be afraid, dive in, go for it. We really like to have people, communicate, get kind of a bigger picture, maybe a group together that can start talking about this stuff. I'm really excited about robots and AI coming out, and I'm seeing all this stuff starting to come out, and I'm like, wow, this is going to be fun. The only thing is we're going to have to try to get John to buy some, dog robots and stuff like that, so we can go ahead and hack on them or something, because definitely I don't think I'm going to be able to afford one of those. So if you have any questions or anything, please let us know. And also there's my email and Dave's email as well.
There are a couple of questions that I have seen go by in Zoom. It does look like somebody asked if your class will ever be remote.
At this time, we are not remote, but we're hoping to get there eventually. And what remote looks like for us, the problem is we have a lot of labs that we provide in the classroom that we can't. It would just cost us so much money. I mean, the cost of the course would go way up for the devices that we have to obtain to do those. So that's the hard part. We may be able to do it without having the lab integration on site, because we do provide tools and some other things that we can do the labs on. But at this time, we're not, but that is something definitely we're looking at in the future of doing.
And somebody said that they're relatively new to cyber. Is this kind of auditing always standalone, or does it get done in conjunction with cyber audits?
I don't know, Dave, I think it's specifically that somebody comes and says, hey, we got this device, we want you to attack it.
Yeah, usually that's going to be a discussion with the target organization, depending on what they want and what the threat model is for the particular piece of hardware. So like in the case of, say, something like a pin pad, we may consider that completely outside of the actual ecosystem that it's deployed in. But with other IoT devices that have a lot of different connectivity options, we might say, hey, it's probably best to look at this from the context of a whole, but that's going to drive your scoping conversation. So if the IoT device lives in some cloud deployment and it's reporting back information to a central repository, obviously it's in the organization's best interest to make sure that people's data is secure, make sure that there's no bleed over. So what you may end up scoping is like a composite engagement where you have to have interaction between the folks who are doing IoT and the folks who are doing, say, the cloud portion, or if a device is packaged with a mobile app, you want that mobile app to be looked at. You want to look at the interfaces that the mobile app is using. So does it directly communicate with the IoT device? Does it communicate with the cloud? And the cloud acts as a proxy for commands going down to it. You want to get as much coverage as possible.
What level of background do you need for your class?
Our class is really targeted at basic. So when you're talking about things like firmware acquisition or interaction with the device. We're looking at JTAG, UART, SWD, the basic protocols that are typically exposed by a microcontroller, and we're analyzing it from that context. Once you get beyond that, given that it's a 2-day course, that's going to be kind of beyond the scope of the class. We'll do static analysis, some dynamic analysis, talk about things you would look for, and we'll touch on those other testing disciplines, but we're not going to like deep dive into a ton of that stuff.
Are there any IoT hardware kits that anyone can recommend to get into IoT hacking?
That's a good question.
Yeah, that's a good question. I haven't really come across anything that kind of encompasses everything. Really, it's specific devices, routers. It depends on what you're looking at, and just jumping in and diving into it. I haven't really seen anything out there that I think there's people that make kits that you can do. That you can actually hack on, but they usually have a course that goes along with that, and that's their proprietary stuff. So it's really tough to get into that.
So it's not like a traditional, like say lock picking kit or whatever. There's different components.
There are images that you can get. You can get images for ESP32s. You can get images for say a Raspberry Pi. But like a lot of other things where you have cross compilation, the tool chain becomes very fragile. And even in some of the kits where there's a Docker image that you can build, we found the Docker image to even be very, very difficult to work with, because over time those projects get updated, and then tools stop working, and you have to get into Docker and figure out why something is broken. And in some cases, you never figure it out.
Do you know of any open source options to virtualize OT ICS?
I know Ashley had a couple of options that she talked about. I know there are options out there for deployment in AWS. I'm not specifically familiar with them, though.
Well, I'll definitely put up a link to Ashley's class, because that is coming up soon, and that's an introduction to industrial control systems. So I'll definitely put that in the chat as well. But thank you guys so much for coming on and giving us an intro to your class, to your intro, your pre-intro, so to speak. We really appreciate it, and it was last minute, so we thank you guys so much for putting stuff together for us. We really appreciate it. And hopefully, people found a lot of valuable information, and it's a little bit of a teaser. Hopefully they'll be able to join us in San Diego or Deadwood. That would be awesome. But I think
definitely super excited to bring this course out. And, we were working on it for a while. Dave and I, we played with this for, we've both been with BHS 7+ years. And we definitely love getting into this stuff. It's kind of a passion of ours. Do it on the side. Just, hey, did you see this? It's funny, if you ever looked at our chat, there's Ray, Dave, and myself in the chat, and there'll be something new put out in there, right, Dave? Hey, check this out. There's a new UART tool, or there's this new way to interact with this device, or there's this tool. And I always cringe when I see that, because then I got to spend an extra 25, 35, 40, 50 bucks. So we have all these tools to buy, and it's just like, hey, gosh, my wife's going to beat me up. It's kind of like buying all the fly fishing stuff, right? She's like, why do you need $200 worth of fly fishing stuff? And you're like, it's IoT stuff. I got to check that out.
Well, that's awesome. And you can definitely tell all of you guys that teach for Anti-Siphon and Wild West Hackin Fest, you're passionate about what you're teaching. And so it makes learning so much more enjoyable, I think. So we thank you guys so much for coming on today, and we look forward to seeing you in San Diego.
Awesome.
Bye.
All right. Well, thanks everybody for joining us. And until next time, everybody have a good day.
Bye-bye.
Bye.
Mm-hmm. Bye.